So we're going to take the 2x and we're going to keep it as a unit all the way through, as if you solved for x. Can everybody get this far to solve pi over 6 plus 2n pi? Cosine x, where's cosine positive? 1 and 4, good. Cosine radical 3 over 2. This is a 30-degree angle. So we're talking pi over 6 and 11 pi over 6. Jonathan, good so far? Okay, we're just locating the two angles. Leave the 2x out of it for a minute. Just like we did for the past week. We just took it out, found out what quadrants they were in, and for all solutions, since this angle was here, we found a coterminal plus 2 pi, plus 2 pi, and we did the same for this one. So we said plus 2n pi, where n is any integer. Now we're going to deal with the double angle. So let's think first. If I have two angles in 2 pi, how many angles, if I double it, should I now have in 2 pi? 4, right? That's what my double angle means. That's the difference from precalc from algebra 2. For algebra 2, you stuck it into those little multiple formulas, you found the signs, but you never really found the angles, unless you worked out the signs and see where they landed. This time now we'll say, well, if you're going to give me double angles, instead of 2 and 2 pi, I should have 4. So in 4 pi, how many should I have then? If I have 4 in 2 pi, I should have 8 in 4 pi. So when I get to the bottom, I should have 8 angles. Now, we're here. Let me get this out of here for a second. So, stay with me. Here we are. I'll work the first one first. Okay, I need to get this out of here. We found this angle to be 2x equals. So I got to divide everything by 2. I need to solve for x. So we found out what your 2x was. So let's divide everybody by 2. Everybody gets divided by 2. This comes out. Now what happens when you divide 1/6 by 2? What do? Keep, change, flip. So keep, change, flip. What does that become? 1/12. So this is now going to become pi over 12 plus n pi. All solutions. All we did was get rid of the double angle. And think about this. I said I needed more, right? So what's half of 30? 15. So if those two 15s will give me 130, and another two 15s will give me the other 30, and I'll get my 4 in 2 pi. So let's work the other part first. 2x is equal to 11 pi over 6 plus 2n pi, because we had two angles, right? First quadrant, third quadrant. Divide by 2. X is now 11 pi over 12 plus n pi. Good so far? All solutions. Now I need to go from 0 to 4 pi. What's my denominator that I have to work with that I notice here? 12. So I'm going to take 4 pi and say, how many 12ths does this give me? Because then I'm going to know where to stop. So in my 12ths, this is going to give me 48 12ths to work with. As soon as I hit 48 over 12, I hit 4 pi. Whatever your denominator is, work the whole thing through in the same denominator. So all you have to do now is start with this guy, 11 pi over 12, and we've got to keep adding n pi. So we have to have that also in a common denominator. So what would this be? 12 n pi, right? So all we're going to keep doing is adding 12 pi. Isn't 12 pi over 12 same as pi, n pi? So we're going to keep adding 12 to this angle. So we're going to start at 1 pi over 12. Your denominators are all the same. Fraction says if your denominators are same, add the numerator. Add 12, I get 13. Add 12, I get 25. Add 12, I get 37. Add another 12, I get 49 pi over 12. But you told me to stop at 48 pi over 12. So this doesn't count. It's out of the domain that I need. Then I take the other one, 11 pi over 12. I do the same thing, and we already know this is going to be 12 pi over 12. It's almost like when we do your angles and we have that denominator, we put the same one here and the doubled one there. It's the same principle. We're just changing your denominator. So I start with 11. I add 12. I add 12. I add 12. If I add 12 more, I get 59 pi over 12. Whoops, that's out of your domain. So did you not say 8 angles and 4 pi? 2 and 2 pi for regular. Doubled it. 4 and 2 pi. 4 and 2 pi. That's right here. And 4 in the other 2 pi. So you should get 8 angles. Right? The good part about this is if you... So, I'm going to start by solving this. I'm going to take the 3x out and just make it an x. Oops. And if you don't have this down, please do this with me. What we're going to do is like we did for the past week. We're going to subtract that from both sides. Does that sound familiar? Right? What angle is that going to be? 45. They rationalized this. So if we unrationalized it, there's your 45-degree angle. Where is sine negative? Third and fourth. Okay. So we know this was a 45. Is everybody okay knowing this is a 45? How many times does 45 go into 180? 4. Look what we do over here. Don't we convert that denominator? Didn't we convert pi over 1 to fourths? Didn't we convert it? We sure did. We've been converting your denominator all along. When we double it, 8 pi over 4. So, here's my angle right now. I'm going to put the 3 back in here. 5 pi over 4 plus 2n pi. Where n is any integer. I don't want to put it up there. Questions before we go on? Jonathan, what bothers you? Rationalizing? Don't worry about the rationalizing. Put this in your calculator. Second sign, do the positive. Find your little reference angle. If you can't find what this triangle is, don't let that hold you up. Put in your calculator in degrees this, but use the positive. That gives you this little reference angle right here. You'll get 45. So don't let that one be the one to hold you up. If we labeled your triangle radical 2 over 2, it's the exact opposite as what we look at. The rationals are now irrationals, and the irrational is irrational. So it kind of throws us off. So don't let that be the problem. Do second sign, just find that reference angle, but remember to put it in positive. It'll get you that reference angle. So now, we're here so far. Everybody okay with this? We have 2 angles in 2 pi. We're going to triple this. So how many angles should we have in 2 pi now? We're going to need 6 angles in 2 pi. We already know our all solution here. This is all solutions when we add 2n pi over and over. Wait, we're going to divide by 3 yet. We're going to finish that part. But that'll give us our all solutions. If we want to go to 4 pi, how many angles should we therefore get in 4 pi? We have 6 in 2 pi. We want to go another 6, 12. We should get 12 angles in 4 pi. Okay? Let's just think this out logically. For multiples of our angle. So now, let's divide these guys by 3. Everybody gets divided by 3. So it becomes x. What does this become? 5 pi over 12. Flip this over. Multiply your denominators. They're right here. Multiply your denominators. Plus 2 pi. I'm just going to put the n at the end. This is an all solution. Okay, we're going to do the same for this guy. So x is equal to 7 pi over 12. Everybody flipping that? 2 pi n over 3. Okay, now, here's our problem. Yes. Well, this is, yeah, I just flipped it. I just moved it around. Yeah. That's your all solution, where n is any integer. So if I'm looking for my all solution, where n is any integer, this is it. Now, I say, okay, I want to go from 0 to 4 pi. What denominator am I going to have to convert everything to? 12. I have a denominator of a 12 and a denominator of a 3. And up here, I have a denominator of a 1. Everybody needs to go to 12. So convert this guy to 12. And what do I get on top? 8 pi. Convert this guy to 12. 8 pi. Convert this guy to 12. Yep, same as the last one. 48. That's my cutoff. That tells me where I'm going to stop. I can also say, okay, I needed 12 angles. I could do 6 with one, 6 with the other, and I would know where to stop, right? But if you convert your final, where you're going to, it probably sometimes works better because you're not thinking. So let's take this guy and start. I start with 5 pi over 12. What do I add to the numerator each time? 8. Everybody see this? From here to here? My denominators are the same. So I'm going to keep adding 8. I'm still in the same pi right now. So I just keep adding 8. 13 pi over 12. Keep going. 21 pi over 12. 29 pi over 12. 37 pi over 12. 45 pi over 12. I've got 1, 2, 3, 4, 5, 6. And if I go any more, don't I pass the 48 pi? Okay, now I'm going to do the second one. Same process. 7 pi over 12. You've got to start with your original angle. Add 12. Good. 15 pi over 12. Do you see a little pattern here? Watch this one. Which will, if I add 5 to this, 8 to this, 23 pi. You could even take these, see them being spaced apart by 2? 31 pi. Add 8. 39 pi. Add 8. 47 pi. See these guys being spaced apart by 2? And these guys were spaced apart by 2. Do I have all 12 angles from 0 to 4 pi now? This is my multiple angles. Question? This was a really good one to... Alright, so we're going to solve this equation, and I'm going to take the 2x out and just put x in here for now. Divide by 3. I'm sorry. Subtract 1. Divide by 3. You notice these are all kind of looking the same thing because we only have radical 3, radical 2, 1, and 2. Those are the sides of all your triangles. Square root. Now when you take the square root, you get a plus or minus. And separate that. That looks like the parts of one of your special triangles, right? So I'm in all 4 quadrants. It's going to be a heck of a lot of angles. Tangent, y over x. What angle is this reference angle? 30. So, I've got, and I'm going to put the 2 back here, pi over 6. We've got 5 pi over 6. Is it okay with you guys if I just do this and do the n pi? This angle will give me this one. And this angle will give me this one. Where n is any integer. Okay, so far? Uh, because for 4, if I find this one and I add 180 to it, I will get this one. So we're taking a shortcut. If I find this one and I go halfway around, I'll find this one. Like for instance, put this in degrees. This is 30. If I add 180 to 30, I get 210. Isn't that this angle? So if I find this one and add 180, I will get its other across the pole. So I only have to do the plus n pi for this. So these are my beginnings of my all solutions. Now I'm going to put the 2 back in here for the multiple angles. If I found 4 angles in 2 pi, and I'm going to have to double this, how many angles should I get in 2 pi? 8. I should get 8 angles in 2 pi. How many angles should I get in 4 pi? 16 angles. Sounds like a lot, but once you get your pattern, all you're doing is adding, adding, adding. So now, let's divide everybody by 2. So I'm going to get x is equal to, what does this give me when I flip it? 11 pi over what? So, sorry. Flip this over. Pi over what? 12. Isn't that a much, much smaller angle? That's a 30. That's a 15, right? Doesn't that make sense? Plus n pi over 2. Okay, leave your n pi over 2. What does this guy give me? Divide everybody by 2. You know how to flip a denominator? Just flip it. 5 pi over 12 plus n pi over 2. So these are my all solutions. Where n is any integer. So if I'm asked for all solutions, I'm done. But before you can do any 0 to 2 pi, 0 to 4 pi, make sure you get this part done. Yeah, what's my common denominator here? 12. So convert this to 12. How many is this? Convert this to 12. I just switched those places around. Convert this to 12. Well, we did this one already, right? So now, all you have to do to get all your angles is just start adding. Your denominators are exactly the same. So start with this one. Put a 1 there in front of it if it helps. And keep adding 6. 7 pi over 12. 13 pi over 12. 19 pi over 12. And we said we should get 8 angles in the first one, 8 angles in the second one. We just have to keep doing this a number of times. 25 pi over 12. 31 pi over 12. 37 pi over 12. 43 pi over 12. I'm counting on these particles. Now, do the same thing for this guy. Start with your original angle. Add 6. Or you can take these and you can do what to them? These are 4 apart, add 4 to those. Depends which way you want to go. 17 pi over 12. I'm going to run that space. What comes after 29? 35 pi over 12? Thank you. And that gives me all 16 angles. That's the easy part. You're just adding the numerator over and over. Yes? Oh, I got 48 pi over 12 because we're going to go from, we want all solutions between 0 and 4 pi. So I want to be able to have all 16 angles from here to here. If I'm having a denominator of 12, I messed this one up, didn't I? If I'm having a denominator of 12 and I'm checking my numerator, and I need to convert this to 12 so that I could check when did I hit my angle. You have a number of ways. You can convert that, or you can figure out I need 16 angles. If I have 2, one has to have 8, the other has to have 8. So when we counted 8, we knew we had to stop. If not, if I don't want to count it in my head and I just want to keep stringing them out, I just need to know where my cutoff is. Otherwise, I just got to cross them out when I figure out I went too far. Okay? So I know what throws you guys off. I know it's the